So again, we're going to be seeing what happens when these two compounds react, and we're going to be writing the answer in this box. So this first box, let's label it number 1. Okay, so this is going to be number 1. And then on your paper, you're going to write that we're solving problem number 1. Okay. So I'll be doing 2 of the boxes with you guys, and then I'll give you guys the rest of the class period to finish up this table. Okay, and it might take more than this class period, so don't stress too much if you don't finish. We'll kind of play it by ear and see how long it takes for everyone to get done. Okay. All right. So in this box, in box number 1, what we're going to be doing is we're going to be writing the reaction for these 2 compounds. Okay. So we're going to be combining NaOH. So we're going to write our equation NaOH. And we're going to be combining that with AgNO3. Okay. So basically the same thing that we've been doing, nothing really new. You guys can probably already tell how we're going to solve this problem. Okay, now one thing I think might be helpful for you guys as you guys are solving this table is if you want to write the ions that these compounds break down into in the box underneath it, that way you can refer back to it later. You can totally do that too. So let's take a look at NaOH. So if we take a look at our solubility table, what's the first cation, the positive ion that comes out of NaOH? Yeah, we got Na plus, and then the negative one is obviously going to be OH minus. So we're going to go back to our solubility table, and let's just write underneath right here that this breaks down into Na plus, and it breaks down into OH minus. Okay, and you can just write it directly on the table. That way when because you're going to be using this chemical again, that way when you go back to it, you don't need to re-look up what it breaks down into. You just kind of have it as a reference. Okay. All right, so I'll give you guys about 30 seconds. I want you guys to write down underneath AgNO3 the 2 ions that this one breaks down into. And then after that, we will basically finish it up. Okay, so take about 30 seconds to figure out what this compound, AgNO3, breaks down into. Yeah. Yeah, it's because Na is one of the more common ions that go into these ionic compounds, and these are the ones we'll be mixing. So it's basically the ones that are cheap for us to buy so that you guys can do your experiments. Yeah, good question though. Alrighty guys, let's take a look at AgNO3. So if we take a look at the table, you'll see that Ag is +1, NO3 is -1, and so that's what we'll be able to put into the box. Okay, so in this box, we can put that the positive ion is Ag plus, and the negative ion is NO3 minus. Okay, everybody good with that? Hopefully not too bad. Okay, now we're going to be finishing up this equation. We're going to figure out what chemicals we can form by mixing these 2 compounds. Now, if you guys remember, it's double replacement. So we take the positive of one and we combine it with the negative of the other one. So positive here, and we combine it with the negative of the other one. So Na and NO3 are going to react. So we're just going to write them down right next to each other. So Na, NO3. Okay. All right, so if we take a look at this, Na is +1, NO3 is -1. So if we put them together, are they balanced? Yes, they got the same positive and negative energy. +1, -1. Okay. All right, the other compound we're going to make is we're going to take the positive of the other one, Ag, and we're going to combine it with OH minus, the negative of the other one. And so we're going to put those together, and we're going to write down what the compounds that they make are. Okay, so we're going to take Ag, so Ag plus. We're going to combine that with OH minus. So if you notice, it's +1 and -1. So this one is already balanced as well. So there we go. We're basically done with our equation. That's what your chemical equation for the first box should look like. Okay. So far, so good? Okay, next thing we got to do is figure out if they dissolve in water or not. So let's put parentheses behind each of the compounds. And I'm going to give you guys about 2 minutes. And I want you guys to figure out what compounds are formed, okay? I want you guys to figure out if it dissolves in water, if it's soluble or insoluble. So I'll give you guys about 2 minutes to do that. One of them might be a little bit tricky. If you don't really get that one, you guys can skip that one. But we'll go over all 4 of them in about 2 minutes, all right? So use your solubility table to figure out if they dissolve in water or not. Okay. So I'll give you guys the answers for the first three. Should be pretty easy. If you line them up on the solubility table, you'll see that NaOH is aqueous, AgNO3 is aqueous, which means it's SOL, it dissolves in water. That's what it means. NaNO3 is also aqueous because it dissolves in water. But the one that I kind of want to go over is AgOH. Now, if you guys take a look on the solubility table and you line up AgOH, you'll notice that there's nothing inside the box, right? It's blank. And so if you look at the table or the key below, it says that if it's blank, the compound does not exist. So basically, it doesn't exist in real life, which means if that compound does not exist, we're also going to write AQ, okay? So if it does not exist, it's obviously not going to form a solid because it's not going to form. So this one is also going to be aqueous. Okay, now if you notice, all four of these are aqueous, right? So if all four of them are aqueous, do we have a precipitate? No, we don't have a precipitate. So we can take a look at the directions. And it says that we write either the formula and the name of the precipitate if it forms for NP. So for box number 1, we can just write NP. Okay. And so on your table, the handout that you got today, you're either on the box, you're just going to write NP, or you're going to write the name of the precipitate if it forms a precipitate. Okay, these equations you're going to do on a separate piece of paper and turn them in afterwards with the rest of this paper when you guys are all done after the lab. Okay. So you got to basically go through each one of these boxes and figure out if there's a precipitate or not. If there is no precipitate, you'll write NP. If there is, you'll write the full name of that precipitate. Okay. All righty. Any questions? You guys all good? Yeah. You can just write NP. This you'll do on a separate piece of paper, just because it takes a. Yeah. Yeah. All right. So just so that we're 100% clear, so people don't mess up. Oh, one more thing. Skip numbers 2 and 3. We're gonna do that on the day of the lab. Okay. Just so that we're 100% clear. On the table, you're just gonna number them and write either NP or the name of the chemical. Okay. On the other paper, you're gonna do the full formula, and you're gonna be turning in that paper as well. Okay. Now, I want to be a little kind to you guys, so I'm going to give you guys the answer for the second one. This one, you guys don't need to do it. You can just write the answer right here. But basically, this one will have a precipitate, and the precipitate's formula is going to be AgI. Okay, so if there is a precipitate, you're going to write the formula and the name. And the name of this chemical is going to be silver 1 iodide. Okay, and you're basically going to go through this entire table. Again, if there is no precipitate, if everything is aqueous, you're going to write NP. If a solid gets formed, you're going to write the formula and the name. Okay? That makes sense? I just want to make sure we're completely clear so that there's no confusion on how you're supposed to solve this. Okay, so this assignment will basically be 2 pieces of paper, this table, and the other paper where you do your equation. Okay, and if at any point you have any questions, you want to double check your answer with me, I can't give you an answer key for this one because it is for a lab. But if you want to ask me a question about a specific one that you might be having trouble with, please ask me. I'll be more than happy to help you guys out. Okay. All right. I'll give you the rest of the class period to work on that. If you want to pick a partner to work with, please feel totally free to do that. All right.